Good morning, children. Sairam. Children, in previous presentation, we have discussed about hybridization, which is a part of the valence bond theory. Explain on the basis of this. And in the live classes, we have already done the valence shell electron pair repulsion theory. So today, I'm starting with the valence bond theory, which comes after your valence shell electron pair repulsion theory. Children, the Lewis structures, they help in writing the structures of the molecule, but they fail to explain the formation of chemical bond. And the Lewis structure also do not give any reason for the difference in the bond dissociation enthalpies. Now children, after that, the Vesper theory gives the geometry of simple molecules, but theoretically it does not explain them and also has limited applications. So, to overcome these limited applications, the two important theories which are based on the quantum mechanical principle were introduced, out of which the first one is the valence bond theory that we'll be discussing today. After that will be the molecular orbital theory that we'll discuss later. Now children, coming to the valence bond theory. It is based on the knowledge of atomic orbitals and the electronic configuration of atoms. It also includes the overlap criteria of atomic orbitals and the hybridization of atomic orbitals. Hybridization we have already discussed in the previous presentation. I have already explained you about the hybridization, its salient features and the type. The hybridizations were of different types: the sp hybridization, sp2 hybridization, sp3 hybridization, sp3d hybridization, dsp2 and sp3d2 type of hybridization we have already done. Now children, so today is your valence bond theory. Today we'll be discussing the orbital overlap criteria. Now children, just consider the formation. We are studying first with the formation of the hydrogen molecule. Consider two hydrogen atoms. The first hydrogen atom is Ha and the second hydrogen atom is Hb. That is A atom of hydrogen and B atom of hydrogen. They are approaching each other and having the nuclei Na for hydrogen A and Nb for hydrogen B. And the electrons are also present in them and are represented by Ea for the electrons of hydrogen atom A and Eb for the electrons of hydrogen atom B. When the two atoms are at large distance from each other, when they are far apart from each other, there is no interaction between them. But as they start coming closer to each other, new attractive and repulsive force start to operate. Now what are the attractive forces and what are the repulsive forces? Now the nucleus of atom and its own electron, between the nucleus of the atom and the own electron, there will be attractive forces. That means nucleus, you all know, is positively charged, electrons you all know are negatively charged, and the opposite poles attract each other, so there will be a attractive force. Similarly, the nucleus of the other atom and the electron of the other atom will also again have an attractive force between the two. Now the repulsive forces will also arise. Repulsive forces will be there between the electron of one atom and the electron of the other atom. Similarly, repulsive force will be there between the nucleus of one atom and the nucleus of the other atom. Now children, you have to remember, if the molecule is formed, that means the attractive force tend to bring the two atoms close to each other. The repulsive force is you can say making the two atoms apart, but experimentally it has been found that the magnitude of the attractive forces is more compared to the repulsive forces. So the two atoms approach each other, they come close to each other, and as a result, their potential energy decreases. Potential energy decreases means they give out energy, and ultimately a stage is reached where the net force of attraction balances the force of repulsion, and the system acquires the minimum energy. And this state of minimum energy corresponds to maximum stability. At this stage, the two hydrogen atoms are said to be bonded together. There is a bond formation between the two atoms, and the molecule becomes stable, and the bond length for the hydrogen atom comes out to be 74 pm, that is experimentally determined. Now, since the energy is released during the bond formation between the two hydrogen atoms, so the hydrogen molecule is stable than that of the isolated gaseous atoms of hydrogen. This is hydrogen molecule. The formula is H2 and the bond length is 74 picometer. The energy so released is called the bond enthalpy. When the two atoms came close to each other, energy was given out. That energy is called the bond enthalpy. So, this is the formation of the hydrogen molecule. Now, children, coming to the orbital overlap concept. Children, it was explained on the basis of valence bond theory that in the formation of the hydrogen molecule, the minimum energy state when two hydrogen atoms came close to each other, their atomic orbitals undergo partial interpenetration. Penetration means they penetrate one inside the other. Partial penetration takes place means this atom goes inside this atom a little bit, and this atom goes inside this atom a little bit. That means the overlapping of atoms takes place. This partial merging of atomic orbitals is called the overlapping of atomic orbital, which result in the pairing of electrons. You all know hydrogen was having one electron, the other hydrogen also having one electron. When the overlapping took place, the two orbitals overlapped each other, which are containing the electrons, and the pairing of electrons occurred. The extent of overlap is decided by the strength of the covalent bond. Higher the energy released, higher is the extent of overlapping. Therefore, according to the orbital overlap concept, the formation of covalent bond between two atoms is resultant of the pairing of electrons of the valence shell having the opposite spin. This is the opposite spin electrons. Now, children, the orbital overlapping, it can take place in many of the ways. Now, you all know about the shapes of orbitals. Now, depending upon the shapes of orbital, see, there can be positive overlapping or there can be negative overlapping also. Now, children, see, when the positive lobe of p orbital overlaps with the positive lobe of the another p orbital, if we are talking about p orbital, then the positive overlapping takes place. But if there is an overlap between the orbitals of the opposite sign, then there is negative overlapping. Positive overlapping favors the formation of the bond, whereas the negative overlapping does not favor the formation of the bond. Next is the overlapping between the s orbital and the p orbital. Now see, when the positive lobe of the p orbital overlaps with the s orbital, there is a positive overlapping. But if the overlapping is between the negative lobe of the p orbital and the this s orbital, then the overlapping is not favored, as it is negative overlapping. Now see, this was the head-on overlapping. Now see, if sidewise overlapping is taking place, then positive overlapping on positive, negative on negative will give a positive overlapping. Whereas if the negative lobe and the positive lobe are overlapping over each other, then it results in the negative overlapping. Now similarly, for the along the y-axis also, positive positive will favor the formation of the bond, negative negative will not favor the formation of the bond. Now next is zero overlapping. In zero overlapping, you all can see that the s orbital cannot overlap with the p orbital sidewise. This sidewise overlapping cannot take place. Similarly, the px orbital cannot overlap with py orbital. Px will always overlap with the px orbital only. So these are negative and positive overlapping, and for orbital s orbital and p orbital overlapping, this cannot work, only this will work. Now children, on the basis of this, there are two types of bonds, the sigma bond and the pi bond. Sigma bond and pi bond. Now children, whenever there is a single bond between two atoms, then such a bond formed is called a sigma bond. When there is a double bond between two atoms, then one of the bond is a sigma bond and the other bond is a pi bond. When there is a triple bond formation between two atoms, then one bond out of that is sigma and two are pi. So you have to remember how sigma bond formation takes place and how pi bond formation takes place. Now children, see, first of all we'll be discussing about the sigma bond. Now sigma bond, it is denoted by the symbol sigma. This type of covalent bond, it is always formed by the head-on overlapping, or you can say head-to-head or end-to-end overlapping of the bonding orbitals along the internuclear axis. It can be formed by any of the following, that is by SS, SP or PP. Now first of all, I am discussing the case of SS. Now see, when you all know s orbital is spherical in shape, so when two s orbitals undergo overlapping, then a sigma bond is formed. Next is sp. When a s orbital overlaps with the p orbital, head-on overlapping is taking place with the positive lobe of the p orbital, then also sigma bond is formed. And the third one is when head-on overlapping between two p orbitals takes place, then again a sigma bond is formed. So for SS, this is the example. For SP, this is the one, and for PP, this is the one. So what is sigma bond? Sigma bond is formed by the head-to-head overlapping of either two s orbital, one s and one p orbital, or two p orbitals. So such bond is called a sigma bond. Now coming to the pi bond. Pi bond denoted by the symbol pi. How a pi bond is formed? Pi bond is formed always in addition with the sigma bond. That means pi bond cannot exist alone. It is formed after the formation of sigma bond if side-wise overlapping takes place. Like this p orbital overlaps with another p orbital sidewise, then a pi bond is formed. This is py. If pz orbital also overlaps like this, if the two come close to each other, then also a pi bond is formed. Now children, you have to remember sigma bond is formed by the head-on overlapping. Pi bond is formed by the side-wise overlapping. In sigma bond formation, s orbital is involved, but in pi bond formation, s orbital cannot be involved. Now sigma bond formation takes place between SS, SP and PP orbital, but pi bond formation can take place between only PP orbital. Now sigma bond can exist alone also, but pi bond cannot exist alone. So children, this was all about sigma and pi bond. And after this, we have already discussed hybridization. So in the next presentation, we'll be starting with the molecular orbital theory. So today, I'll wind up with this. Thank you. Sairam.